Now let us discuss the combination of resistances. So basically there are two ways in which we can see the combination. One is a series combination, another is parallel combination. So first one we are going to discuss the series combination. Now when do we say that two or more conductors, they are connected in series? So when some conductors having resistances R1, R2 and R3, so these are three resistors having resistances R1, R2 and R3, they are connected end to end. Here end to end is important word, that they are connected just one after other and they make a single branch. Okay, so they should be part of a single branch. Then we say that R1, R2 and R3 are connected in series. Now if two or more resistors they are connected in series, then what happens? Since they are part of the same single branch, what is going to happen is the same amount of current will flow through all of them. Once any amount of current enters one resistor, that is R1, then R2 and R3, they are part of the same branch, so same amount of current will pass through all three of them which are in series. So in series, this is the important thing, that current is same through all of them. Now next is voltage drop across each. So what is voltage drop across each? So Ohm's law says that V is equal to IR. V is the potential difference or voltage drop across each of the resistance, I is the current in it, and R is the resistance. So since current is same, right, but resistance values differ, so voltage drop across each will be different, and we are going to call them V1, V2 and V3. So voltage drop across each is different. Next, what we are going to do is we are going to write the total voltage drop across all of them. So total voltage drop is, let us say total voltage drop is V, and that is nothing but V1 plus V2 plus V3. So I am going to say total voltage drop is the addition of potential differences across individual resistors. And what is V1? Apply Ohm's law just for R1. So that is V1 is nothing but IR1. What is V2? IR2. And what is V3? IR3. Now I am saying let it be equivalent to, so let the combination of these three resistors R1, R2 and R3 be equal to just a single resistance, that is R. Now same voltage, see across this entire combination, what is the voltage? V, that is V1 plus V2 plus V3. So same voltage has been applied, and let same amount of current capital I also flow through it. So what can we say? We will be saying that for this we can again write V is nothing but I into R, because total voltage drop across this resistance is V, and that should be equal to current in it, which is I, and R. R is what? R is the equivalent or total resistance of R1, R2 and R3 combined when they are connected in series. So we can write V is equal to IR. And now if we are saying that this V and this V is same, we can just equate them, and when we equate this IR to this, we can solve them for R. So we just equated it, and then we are saying that equivalent resistance of series combination is going to be coming to be R equals to R1 plus R2 plus R3. What will happen? We will just cancel I from here, like from entire equation, because I is the same amount of current. This I is the same because all three resistances are having same current, and this I is nothing but the current in this situation, which also we assume to be I, because this resistor, single resistance, just represent all of them all together. So in series, again I am repeating, in series what you can do is you can simply say that you just add all the resistors to get the total resistance of the branch. So if two or more resistors they are in a single branch, then we will say they are in series, and we can simply add their resistances. Now let us do a question. So this question says that find the current in the circuit. This is a circuit, and in this circuit if you see, this is a single branch, right? So this is a single branch, and across AB, from A to B, if we say there are three resistances connected, 1, 2 and 3 ohm, and they are nothing but they are in series, so I can say that they can simply be replaced with a single resistance R, and R would be equal to what? 1 plus 2 plus 3 ohm. That gives you basically 6 ohm. So this is the total resistance of this entire thing. Now just remove all these three and replace it with the 6 ohm volt resistor, and then we will say a 30 volt battery is connected. So apply Ohm's law, we will say V is equal to I into R, and V is basically voltage applied is 30 volt. I, we have to get the current, and resistance, the entire resistance is 6 ohm. So I comes to be 30 by 6, that is 5 ampere. So this is the answer. Now next type of combination is parallel combination. So what is parallel combination first? So if three resistors, they are connected as shown in the figure. So they are connected like this. Then we say they are basically in parallel. What is the major thing which are we can notice? The starting point is same. All of them are starting from this point, and all of them are also ending at the same point. So they are basically, their ends are connected to a common point. If their ends are connected to a common point, then what would happen? Then basically the potential difference across all the resistance is going to be same. So let us say that this point is A and this point is B. Then I am going to say whatever is the potential difference across these 2 points, point A and B, is the potential difference across R1, is the potential difference across R2, and is the potential difference across R3. So all of them have the same potential difference across each of them if they are connected in parallel. But current, what about current? Current, if I amount of current is coming for the entire combination, then we will say that current is going to split. So some of the current will go in this branch, some of the current will go in this branch, and some of the current will go in that branch. How that is decided, we will discuss later. But we will say that let I be coming, I1 be the current which is going in R1, I2 be the current which is going in R2, and I3 be the current which is going in R3. So what can we write? We can write that total amount of current which is coming is I1 plus I2 plus I3, because this is the current which is coming and it is getting splitted. And now what is I1? So just think about R1. So we are going to say that potential difference across this R1, that is V is equal to IR, this is the Ohm's law. The current in R1 is I1, the resistance of R1 is R1, and what about the potential difference across this? Potential difference across this is the potential difference provided by the entire battery, which is V only. Similarly, for R2 also we can write V is equal to I2 R2. So from here, the value of I1 comes to be V by R1. So the I1 is nothing but V by R1. Similarly, you can write that I2 is V by R2 and I3 is V by R3. Once we write this, we can just replace this entire thing with a single resistor R, and we will say if R is the total resistance, equivalent resistance of the parallel combination, then we will say that again I will just make this circuit. So I will say V is equal to the total current into that R. So we will get the total current is V by total resistance, total voltage divided by total voltage. Now this current and this current is same, so we can just equate this and this, and what we get is this equation. So V by R is equal to V by R1 plus V by R2 plus V by R3. And here, as you can see, we can take V common in both sides and we can cancel it out. So this is the formula which we get for parallel combination. It is 1 by R1, 1 by R, 1 by total resistance is 1 by R1 plus 1 by R2 plus 1 by R3, and so on. If there is like fourth resistor also connected over here in parallel combination, then we will say that the total resistance is like, it will be same expression, just we will write plus 1 by R4 also over here. So what is the conclusion? Conclusion is basically if two or more resistors are connected in parallel, then addition of reciprocal of all of them gives you the reciprocal of total resistance of that particular combination. So this is a question which we are going to discuss, and it says two resistances which are 3 ohm and 2 ohm, they are basically connected in parallel connection, as you can see, and a potential difference of 12 volts. So this is a 12 volt battery which is providing a 12 volt potential difference across this combination is applied. Then we need to get the equivalent resistance of this parallel combination. So they just want what will be the total resistance of this combination. So total resistance of this combination, we can simply apply the formula 1 by total resistance is equal to 1 by R1 which is 3 plus 1 by R2 which is 2, and eventually if you solve you get this is 6 and this is 5. So the total resistance is, again you reciprocate it, so 6 by 5, and that gives me 1.2 ohm. So 1.2 ohm is the total resistance of this entire combination. So this is a very simple combination. Later we are going to discuss some more complex combinations. So the potential difference, the total resistance is 1.2 ohm for this entire combination. Now next question they are asking is that find the circuit current. If you are going to find the current through the battery, then you have to again apply V is equal to IR. It just V has to be the potential of the battery, I is the current through the battery, and what about R? R is the total resistance across the battery, basically of the entire circuit. So we have already found that total resistance is 1.2 ohm. The V, the potential difference of the battery or total potential difference applied across this battery is 12 volt. And current they are asking, circuit current. So we'll say circuit current is nothing but this V by R, or V is equal to IR. So V by R gives you 12 divided by 1.2, and that gives me 10 ampere. So this is the current which is coming through the battery. So this current coming is 10 ampere. Now next question they are asking is that the branches current. So we already know that this 10 ampere current is coming. So there are various ways. So either you can distribute the current in the ratio of resistances, that is a different thing, or what you can do here is, you know that the potential difference across this combination is 12 volt, but the potential difference across both of them is also 12 volt. See, whatever is the potential difference across the combination in parallel combination, that is the potential difference across each of them, and that is nothing but 12 volt. So potential difference across R1 is also 12 volt, potential difference across R2 is also 12 volt. So for R1, what can we write? V is equal to I1 R1. V is potential difference, it is 12. I1 is the branch current in R1, and R1 is basically 3. And that gives me 12 by 3. So I1 comes to be 4 ampere. So this is the current in this branch. So this current is nothing but 4 ampere. What about the second branch? For R2 we can write V is equal to I2 R2. So again it is 12 volt. It is equal to the branch in second current in second branch, and R2, the second resistance, is 2 ohm. So that gives me that I2 is equal to 6 ampere. And that says ki I2 is basically 6 ampere. If you see this, that total 10 ampere current is coming, and in this branch 4 ampere is going out of that, and rest of it is 6. So that is going in the second branch. So this is 10 is basically 6 plus 4 also. Now next topic which we are going to discuss is color code of the carbon resistor. So basically what is this topic? So in laboratory when we do experiment, so we get a carbon resistor. So carbon resistance, what are carbon resistors? So carbon resistance are basically cylindrical, and on those cylinder there are strips. So there are generally 4 strips. So the value of each carbon resistance is indicated by these 4 colored bands marked on the surface of the cylinder. So what are these color bands? So this is how they look like. They look like a cylinder, and there are 4 strips. So now first strip, basically this tells the digit 1. The second strip tells the digit 2. The third strip tells the multiplier, and the last strip, sometimes it is absent also. So this tells the tolerance. So digit 1, digit 2, multiplier and tolerance. How do we write it? Let's just see an example. So first, like, we need to understand the color. So there are these many colors, and each color represents a digit. If we are talking about digit 1 and digit 2, then each color also represents a multiplier. To be precise, it is just 10 raised to power digit. Like if black represents 0, then multiplier is 10 raised to 0, which is 1. Brown is 1, so this is like 10 raised to 1. So to be precise, it is just 10 raised to power digit. And red represent 2, so this is 10 raised to 2. Orange represent 3, so this is, if it is multiplier, it will be 10 raised to 3. And tolerance is only generally in 2 color, that is gold and silver. For other, like, tolerance is not there. So tolerance is either found in golden color or in silver color, or otherwise it is absent. So if it is golden color, then tolerance level is plus minus 5%. If it is silver color, then tolerance is plus minus 10%. Let us see an example how it actually works. So for example, there are 4 strips. So suppose the color on the resistors shown in the figure are basically brown. The first strip is brown, the second is yellow, third is green, and the last is gold. So what does brown represent? You can check the value from the table. Brown represent 1, yellow represent 4, green represent 5, and the gold represent 5%, right? So what will be the value of resistance? This is 1 and 4. So this is first digit, this is the second digit. So we get 14. This is what? The third strip represent the multiplier, and the green represent 5. So it is basically representing 10 raised to power 5. So multiplier is going to be 10 raised to power 5. And what about gold? Gold is 5%. So tolerance level is plus minus 5. And that is going to, so this is going to be the value of the resistance of the resistor which are having these 4 strips in this particular order. And which is also written over 14 into 10 raised to power 5 plus minus 5%. If you want to change it, so what you can do is like you can make it 1.4 into 10 raised to 6. So this is simply 1.4, 10 raised to 6 is mega ohm, and plus minus 5%. What does that mean? That means that you can simply get the 5% of this and you can write it over here. So 5% of 1.4 mega ohm is 0.07 mega ohm. So we can write it is 1.4 plus minus 0.07 mega ohm. Plus minus 0.07 is basically the error. Now, sometimes the tolerance level, tolerance band is missing. So the last band I told that, as I told that the last strip is sometime missing. The last golden or silver is not there. There are just simply 3 strips. So in that case, we will say that the tolerance level is basically 20%. So if there are only 3 strips, then last tolerance level, which is by the way only golden or silver, they are not there, then we will say tolerance level is plus minus 20%. So that type of carbon resistor have maximum error.